All right, I'm taking a chance here. I got no battery left. We'll see if I can sneak this one in. All right, lesson 16, surface area and volume. Let's use volume and surface area to solve problems. Volume, I think of it as like airspace. How much airspace does it take up? Surface area. Ooh, my handwriting's already bad. Anyway, surface area is add up the areas of all surfaces or faces. So add up the areas of all the surfaces or the faces. So the zoo wants to give the elephants as much space as possible in a rectangular closure meant for feeding. The zoo has 180 feet of fencing. What should the dimensions of the rectangle be? Be prepared to share your reasoning. In order to save time, rather than spend all the time building a bunch of rectangles, I'm going to give you the concept. The concept is that for a given perimeter, like 180, a square maximizes area. So if we're talking about rectangles, for a given perimeter, in this case 180 feet, a square maximizes the area. So if you have 180 feet, you got to divide that by 4. That way you'll get the length of the sides. 180 divided by 4 equals 45. So you are going to build a square. And your dimensions are 45 feet by 45 feet. And your area is 45 times 45, which equals 2025. And that's square feet. My challenge to you is try to beat this number. You can't. You might be able to with the circle though, but that's the max area you're gonna have with 180 feet of fencing. This is the concept. For a given perimeter, a square maximizes the area. Okay, next problem. Again, flying through this because I'm low on battery. Woo. Get a short video. All right, find a set of dimensions for a rectangular prism with volume 60 cubic units. Calculate the surface area of your prism. Add your data to the class chart. All right. We're not going to do a chart, but let's draw a rectangular prism. It's always a good place to start, just to organize your thoughts. All right, there's a rectangular prism. A rectangular prism has a length, a width, and a height. A length times a width times a height. That's going to be your volume, right? and it gives it to you is 60. Now you have 1, 2, 3 unknowns. And you can actually find a set of dimensions for that, because 60 breaks down into 10 by 6 as one example, and then 10 breaks down into 5 by 2. So why don't we try this? There's a number, tons of possibilities. But let's say the height is 2. Width always has to be less than the length. So there you go, 652, that'll work. Now I gotta get surface area. Ugh. Surface area is tough. But you got 1, 2, 3, and then you got a side right there. Then you got a back, and then you also have a bottom. There's 6 faces on a rectangular prism. Let's go, let's switch to a pencil. Let's go front and back. So front and back, they're gonna be the same. You've got 6, and that's a 2, right? So front and back is 6 by 2, which equals 12. Let's go side, let's go left and right.
Good morning, Pumas. Pardon the interruption. We're going to start transitioning to SBAC testing.
5
if you are an
times
11th
2
grader on the first floor, please make your way to the
10.
library now. 11th graders who are SBAC testing on the first floor, please make your way to the library now.
Last but not least, we're gonna go top and bottom. So like this part, plus the one on the bottom. That's gonna be 6, and the width is 5. So 6 times 5, which equals 30. So this is the area of front and back. This one right here. All right. And there's 2 of them. 12 times 2 is 24. Left and right. Here's left and right. Area is 10, and there's that one plus that one. So that's times 2. So it's 24 plus 20. And then last but not least, the top and bottom is 30. So 30 and 30. So that times 2,
If you are a
60.
junior on the second floor, please begin to transition to the cafeteria for SBAC testing.
So your surface
All
area
juniors on the second floor, make your
equals
way to the
20
library.
plus 60,
Sorry,
which is 80,
cafeteria for SBAC testing.
plus
Thank you.
24, which is 104. And then you gotta go square units, because surface area is just like area, and you have to put it in square units. Now that was just one example of surface area. Let's look at number 2. Tough problem, fun problem. A lithium ion battery. Here's the shape of lithium ion batteries. You'll see like a lot of lithium ion batteries in this shape, which is kind of cool. Sometimes they have those like things right here. All right, lithium ion battery is a lithium.
Third floor juniors, please make your way to the cafeteria for SBAC testing. Thank you, teachers and students.
All right, lithium ion battery contains a rectangular prism made of lithium. This is a key point right here. The energy in the battery, so the energy in this battery is proportional to the surface area of the prism. What does that mean in useful information? That means as the energy goes up, so does this, or as the surface area goes up, so does the energy. So what you want to do on this, so the goal for your battery, if you're a battery maker, don't be loud in the hallways, it's really annoying. All right, battery maker, say you make these batteries. You want to maximize your surface area. That's the goal. Maximize your surface area. Because if you do that, you're gonna have a high surface area and your battery is gonna have a ton of energy, and that's what you want. All right, so assume the lithium battery has a fixed volume of 60 cubic millimeters. All right, the volume is 60. That's our volume. We're given that. Find the dimensions. So find the dimensions, kind of like before, of this prism, rectangular prism, with this volume, 60, that maximizes its surface area. That's what you got to do, maximize your surface area. The difficult thing is you don't really know the concept. So I'm going to give it to you. So the concept is here, and this is a critical thing. I'm going to box it, it's that important. And it's kind of shocking based on what I just taught you about squares. Like a square will maximize area for a given perimeter. Remember the elephants and the fencing? So here's your concept. I'm going to write it out. Compact shapes. Example, cube or a sphere. So a compact shape, like a cube or a sphere, minimize surface area for a given volume. Here's a cube. Cube, every side is a square. That's how you draw a square. So every side is a square in a cube. Because a cube will minimize surface area, you want to avoid the cube. You don't want a cube, because your goal is you want to maximize surface area. You don't want to minimize it, right? Because a compact shape like a cube, like here, actually minimizes surface area for a given volume. Okay, so you want something more like this, which is why lithium-ion batteries are typically in like this shape. Like you want something like this. This is what you want. Yeah, your volume's 60, right? So we need to find some some measurements that are going to increase surface area. So I'll give you one. 60 and 1. And then we're going to do it again. 60 and 1. So here are your measurements, your dimensions. So 60, 1. If you need to draw it right here to help you visualize it, that will typically help. So you got a 60, a 1, and technically you need another 1. Where is it? Right here. Wait, no. Let's make this 60 and this 1 so I'm not confusing you. But anyway, that's 60 by 1 by 1. I should have drawn it more like this than I did earlier, but let's draw it like this so it looks right. All right, so 60, 1, and 1. That's going to maximize your surface area. And try me out if you want to run the surface area like we did earlier. Try me out on a bunch of different options of 60. Whew. Maximizing in 3 dimensions. So you got to remember this right here. Compact shapes like the cube or sphere minimize surface area for a given volume. So if you want to get the most surface area, you want to avoid like the cube. You want to go with something like this. Now, how does that help you in the real world? Well, think about Christmas. Everybody loves Christmas, right? All right, so Christmas, you have to wrap what? Presents. So if you want to minimize your wrapping paper, because wrapping paper costs money. Try to wrap gifts in cubes or spheres, because these two right here, cubes and spheres, are compact and they will minimize surface area. So if you want to minimize your wrapping paper costs, try to wrap your gifts in cubes or spheres. And it's no wonder why so many shipping boxes are in this shape, cubes. Because a cube, less cardboard, surface area, less gift wrap. Amazon knows. Cubes are a good option for minimizing cardboard and the wrap. So anyway, that's 16.2. Cool. All right, 16.3, assume a spherical elephant. Okay, so this is like a joke. There's like a, I think it's in physics. There's like an ongoing joke, like assume a spherical elephant. Like, huh? Okay, so you got an elephant in the sphere. There's a trunk and a horn. You got a big old elephant. This is the worst elephant I've ever drawn, but it's okay. So you gotta assume an elephant is in a sphere. Okay, spherical elephant. All right, for a sphere with radius r, its volume. Here's your volume formula for a sphere. Is 4/3 pi r cubed, and its surface area is 4 pi r squared. All right, we just got to plug in numbers. Not that scary. Let's model an elephant with a sphere that has a radius of 4.5 feet. Okay, what is the volume of the elephant? That's why I like box the things that are important. So volume equals 4/3 pi r cubed, which equals 4/3 pi 4.5 to the third power, which equals, I like to start with exponents because of PEMDAS, 4.5, exponent 3, 91.125. So 4/3 pi, 91.125. Okay. That could be rewritten as 4 times 91.125 times pi, all divided by 3, because you can do that. So 91.125 times 4 times pi equals 1145.11 divided by 3. So your volume is 381.7. That's the nearest tenth. And then we're in feet, so feet to the third power. That's your final answer for the spherical elephant. Got the volume. All right, what's the surface area? Same deal. You just go with what you know. And this was surface area. So you say SA equals 4 pi r squared. Okay, whatever. That's the formula. Somebody figured that out. I can't believe that. Anyway, it's just like, it's crazy to me, like these people who figure these things out. Like, so smart. All right, surface area of the spherical elephant. This is a shadow, in case you were wondering. There's my elephant. Got 2 tusks, right? Anyways, all right. 4 pi radius 4.5 squared. You just plug and play. That's it. Boom. Radius 4.5. So we just get a calculator out. 4.5 squared is 20.25. So 4 pi times 20.25. Parentheses mean multiplication. 4 times 20.25 is 81. And don't forget about the pi. And then it's surface area. So you have to say feet to the second. So 81 pi. Square feet. All right, let's model a snake with the cylinder. All right, model a snake. That means like we're drawing a cylinder in the shape of a snake. All right. And we need a cylinder, so we're going to do that. All right, cylinder in the shape of a snake. This is our snake cylinder. Okay. Length is 3 feet. All right. It's our snake. Snake's 3 feet long. It's a pretty small snake, if you ask me. Diameter is 0.2 feet. So diameter in a circle is all the way across. So diameter is 0.2, which means the radius is half of that. 0.2 divided by 2. That's going to be your radius. So what is 0.2 divided by 2? It's 0.1. So your radius is 0.1 feet. You can rewrite that as 0.1 feet if that's easier for you. All right, so our radius is 0.1. Now you just do the volume of a cylinder, because we're a cylinder snake. And you don't need to memorize these, but I do, and it helps. But when you get here, you're like, all right, what's the volume of a cylinder? Okay, let me look at the board. A cylinder is just simply pi r squared, because it's a circle on the base, times your height. Okay, and we have everything. So the volume is going to be pi times 0.1 squared times your height of 3. There's 0.1, it's already there, squared 0.01, so pi times 0.01 times 3. 3 times 0.01 is 0.03 pi is your volume. And we are in feet, so you go feet to the third. There you go, volume. What's the surface area of the snake? What's the surface area of a cylinder? I should know this. Shoot! Hold off. I don't have the surface area formula for a cylinder memorized, and my phone's about to die. So you would need the surface area formula for a cylinder to solve this, and then you would just plug in your givens. Height would be 3, radius is 0.1. But Google this, figure it out. I forget what it is. It's so rarely used. Fisher forgot. Whoops. And my phone's gonna die. Nope, I'm gonna go figure it out. I got a computer. Hang on one sec. Actually, it's probably in the workbook. What do you want to bet? 16. Let's see. Surface area. Let's see if it's in the workbook. I bet it is. Surface area. Show me surface area. Jeez, there's another one. I'm skipping 16.4. Wow. That's 16. It's a doozy. I shouldn't have these memorized. I'm a geometry teacher. But I need surface area of a cylinder formula. Okay, let me go find it. It's not in the workbook. Two pi RH plus 2 pi r squared. 2 should still be recording. Okay. There is your surface area formula for a cylinder. Whew. 2 pi RH plus 2 pi R squared. All right. We got the R, we got the height. Remember, R equals 0.1. Height equals 3 feet. All right. All right. All right. So let's just plug them in. Surface area, 2 pi 0.1 times 3 plus 2 pi 0.1 squared. All right. Here we go. It's going to equal 2 pi times 0.3 plus 2 pi times 0.1 squared. 0.01. 2 times 0.3 is 0.6 pi plus 2 times 0.01 is 0.02 times pi. Since they're both pi, you can add them together. 0.6 plus 0.02 is 0.62 pi. Whew. And we are in feet, and it's surface area, so you gotta say square feet. So the surface area is 0.62 pi square feet. If I made a mistake, sorry. I haven't done surface area of cylinders in so long. All right, surface area to volume for each animal. So let's start with the elephant. Surface area of the elephant is 81 pi. Volume was 381.7, no pi, right? Yep, okay, so 81 pi. Yeah, this problem's brutal. 254.5. 254.5 divided by 381.7. 0.67 surface area divided by volume. Let's look at surface area of the snake. Surface area to volume. So that'll equal surface area 0.62 pi divided by volume 0.03 pi. These cancel, so 0.62 divided by 0.03 is 20.67. So the surface area divided by the volume for the snake is 20.67. And for the elephant, it is 0.67. I'd love to go into surface area divided by volume and what the point of it is, but my phone's about to die, and I'm already at a 30-minute video, and we'll talk about that later. All right, just stay focused. Try your best. Embrace the struggle of learning. Just embrace it. Good example is Street Fighter. You put it on level 1 difficulty, it's who cares? Nobody cares if you put it on level 1. If you put it on level 4, you actually get the story of the characters. But you have to go all the way up to level 4 to get like Ryu's backstory. So they reward you by doing things that are difficult. Do difficult things. Get rewarded, right? Like in video games, you get Ryu's backstory, and then you're more invested, right? Throw a Street Fighter on level 10, I can't even get a point. It's so hard. Mike Tyson's Punch-Out was a good example, too, of a difficult video game. But it's so much fun when you can do difficult things. All right. Keep challenging yourself. Try your best. Stay focused. And embrace the struggle. All right, bye.